industrial factory setting refer to health damage that occurs where workers are exposed to mercury vapor or mercury-containing material during manufacturing, processing, maintaining, and demolition activities. In factory, mercury is often present in equipment such as fluorescent lamps, electrical switches, thermometers, batteries, and certain chemical processes. When these materials are broken, heated, or improperly handled, mercury is released into the air as a toxic vapor that workers can inhale.
Chemical in lamp fluorescent is mercury, gas inert, and phosphorus.
In the workplace, Nayash explained that mercury exposure increases when temperature rises because mercury evaporates more easily in warm conditions, resulting in higher level of mercury vapor in the air, especially in enclosures or poorly ventilated area, which increases airborne contamination and makes it harder to control exposure during industrial activities. Occupational exposure limit for PEL 0.05 mg per cubic meter, TWA limit of 0.05 mg per cubic meter for the 8 hours, TLV 0.05 mg per cubic meter as an 8 hours time weighted average. Last, for the short-term exposure limit, Nayash recommended a 0.05 mg per cubic meter 10 hours work shift.
Next, I will explain the background of manufacturing process of fluorescent light bulbs. The fluorescent light bulb is an energy-efficient lighting device. It produces lighting through excitation of phosphor coating inside the glass tube. It also requires precise industrial manufacturing process. The first process of fluorescent light bulb is the glass tube formation, which is molten glass formation, tube drawing, and cooling and cutting. During the process, glass manufacturing can produce silica dust, which means the inhalation of silica may cause silicosis and lung disease. The second process is phosphor coating, which is identifying the phosphor types and application method. These chemical coating materials may produce dust and fumes that irritate the respiratory tract. The third process is electrode formation and placement, which is tungsten coiling, insertion of double-coiled tungsten. Welding during the electrode assembly can release welding fumes. These fumes may cause respiratory irritation and chronic effects. Fourth, gas filling and mercury addition, which it has vacuuming, gas insertion, and mercury dosage. A lot of workers will expose to toxic gases and mercury vapors, which can affect the lungs and blood system. Next, the tube sealing and electrode wiring, which it has pin sealing and aging process. During the heating and sealing process, it may release vapors and airborne particles, which can irritate the lungs. After that is base addition, which is for the preparation and base attachment. During the base addition process, it may involve metal materials and adhesive that can release fumes or dust. This exposure may cause skin and respiratory irritation. The next point are testing and quality control, which means the fluorescent light bulb will undergo testing or discarded or reprocessed. Workers may be exposed to the toxic gases during the bulb testing if there is leakage or occurs. Last but not least is packaging and handling process. During the labeling and packing, it may have some broken fluorescent bulbs which can release mercury and glass dust that may harm the workers' health.
Now, I will move on the discussion part. I will explain one of the routes of entry, which is direct contact. Route of entry refers to the hazardous substance enters human body. This is very important because the route of entry affects how fast the chemicals absorb. In this case, mercury can enter through direct contact with the skin. For example, worker may accidentally touch liquid mercury while handling materials. Although skin absorption is not the main route, it can still contribute to mercury exposure if safety measures are not followed. Next, another important route of entry is inhalation. This is the most common and dangerous way mercury enters the body. In workplaces like fluorescent lamp factory, mercury can be released into the air as vapor, especially when lamps break during production. When workers breathe in the contaminated air, the mercury vapor enter the lung and quickly pass into the bloodstream. Now, I will explain the health effect of mercury exposure. Mercury mainly affects the brain and central nervous system. Most common symptoms include tremors, which means shaking hand, memory loss, and mood change, such as irritability. Long-term exposure can also damage important organs like the kidney. Mercury exposure can also affect the respiratory system. Workers may experience symptoms like coughing, chest tightness, and difficulty breathing. In addition, it can cause irritation to the skin. In some cases, it may lead to the rashes or allergic reaction. Now, I will explain the control and preventive measures to reduce mercury exposure in the workplace. There are several types of control that can be applied to ensure safety. First, engineering controls are very important. This includes using proper ventilation system, such as local exhaust ventilation to remove mercury vapor from the air. This helps to reduce the amount of toxic substance that workers may inhale. In addition, equipment should be well maintained to prevent leaks or accidental release of mercury. Next, administrative control should be implemented. This involves providing proper training and education to workers about the hazard of mercury and how to handle its safety. Work procedures should be clearly defined and exposure time should be limited to reduce the risk. Regular monitoring and safety inspection are also important to ensure that all safety measures are allowed. Furthermore, personal protective equipment or PPE must be used as an additional layer of protection. Workers should wear gloves, masks or respirators, and protective clothing to minimize direct contact and inhalation of mercury. Finally, proper storage and disposal of mercury are very important. Mercury should be stored in sealed containers and handled carefully to avoid spill. Waste material containing mercury must be disposed of according to safety regulation to prevent environmental contamination. Overall, by applying this control and preventive measure, the risk of mercury exposure can be significantly reduced, ensuring a safer workers' environment.
So now we move to toxicological concept. The first one is distribution. Distribution means how a chemical moves from the bloodstream to different organs and tissue after it enters the body. The first process is after inhalation bloodstream. Workers inhale elemental mercury vapor and absorb in the lungs and enter the bloodstream. Next is movement to the brain. Mercury crosses the blood-brain barrier and accumulates in the central nervous system. And after that, conversion and trapping in tissues. Hg is converted into Hg2 inside brain. This form cannot easily leave the brain and becomes trapped in brain tissues. Then distribution to other organs. Mercury also travels to the kidneys, where it accumulates and causes toxicity, and the lungs, which are the initial site of irritation. And the last one is accumulation over time. Repeated inhalation can cause mercury accumulation due to the elimination. Next is metabolism biotransformation. Metabolism biotransformation is process where the body chemically changes a substance into another form, usually to make it easier to eliminate. Firstly is initial form before metabolism. Workers inhale elemental mercury vapor Hg, which is lipid soluble and easily enters the brain. Second is conversion in the body. Hg is oxidized to Hg2+ in the brain and liver. Next, why this conversion is important? Hg enters the brain easily, but Hg2+ cannot leave, causing it to be trapped and become more toxic. After that is effect of metabolism on toxicity. Causes accumulation in the brain and can lead to chronic neurological symptoms. Lastly is mechanism behind the case. Daily inhalation of Hg leads to the brain accumulation of Hg2+, causing persistent symptoms and worsening neurological effects. And the last one is excretion. That means the body process of removing toxic substance from the body. First, main roles of excretion. After metabolism, mercury is mainly excreted in urine with smaller amounts in feces and sweat and saliva. Next, rate of excretion. Hg2+ excretion very slowly, which binds strongly to tissues and can cause accumulation in the body over time. Then, accumulation in organs. Mercury accumulates in the brain and kidneys because Hg2+ is trapped in tissues. After that, health impact of continuous mercury exposure. Workers are exposed
they lead to mercury vapor. So, mercury accumulates and can cause chronic toxicity and long-term neurological damage. And lastly, biological monitoring. Mercury is extracted in urine, so urine tests are used to monitor exposure. This means high level indicate high exposure. This slide explains the risk of mercury exposure in fluorescent lamp factories. The workers in the factory are at risk because they are exposed to mercury vapor during their work. The type of exposure is chronic exposure, which means they inhale mercury vapor every day for a long period. Several factors can increase the risk, such as high concentration of mercury vapor, long duration of exposure, poor ventilation in the factory, chemical substance, and not using PPE while working. The level of risk is high because workers inhale mercury vapor daily, and mercury can affect the brain and can cause long-term neurological damage. As a result, the possible outcomes include chronic toxicity and an increased chance of neurological damage.